combines an imaginary number with a real number. So for example, a plus bi. A and b are both real numbers. A is our real part, and b times I is our imaginary part. We're going to be looking at complex numbers on a coordinate plane. We're going to be looking at absolute value of complex numbers, which, as a reminder, is distance from 0. But when you're on a coordinate plane, it's distance from the origin. So as a reminder, the distance formula is listed for you as well if you want to jot that down. Today's lesson is section 5.9a, operations with complex numbers. Our essential question: when we're operating with complex numbers, I think it's very similar to operating with algebraic expressions. So I'm going to have you compare those. First of all, adding and subtracting with complex numbers. So when we're adding complex numbers, we add the real part. -3 plus 7 gives us 4. And we add the imaginary part. So 5i minus 6i is -i. When we subtract with complex numbers, I like to distribute the negative sign so that I'm actually adding. It's easier to keep track of adding. So I get -3 minus 8i plus -2 plus 9i. So when I combine my real parts, -3 plus -2 gives me -5. -8i plus 9i gives me a positive I. When you graph with complex numbers, the x-axis becomes the real axis, or the real number part of the complex number, and the y-axis turns into the imaginary axis. So when we're graphing point A, 3 plus 5i, I'm going to go right 3 because it's positive, and up 5 because that's also positive. So right here would be point A. For point B, we have an imaginary part, but no real part. So I'm going to go left and right 0, down 4 on the imaginary axis. So there's point B. And then point C, left 6 on the real axis, and this is plus I, which is really 1i, so I'm going to go up 1. And that would be point C. In order to evaluate absolute value with our complex numbers, we need to understand what I squared ends up being. So when I take I squared, remember squaring means multiply it by itself. So it's the same thing as I times I. Well, I is the square root of -1. So I have the square root of -1 times the square root of -1. When you're multiplying or dividing with two radicals, you can combine them under one radical. So this becomes the square root of -1 times -1. Parentheses might be easier to see. -1 times -1 is 1, and the square root of 1 is 1. So whenever you see I squared, it's the same thing as +1. All right, absolute value. Remember, we're looking at absolute value on a coordinate plane. So we're going to find the distance of this point, 3 plus 5i, that we actually plotted a couple of screens ago, from 0. So just to give you a quick sketch of what we're looking at. So our point is here. Remember, this is our real axis, and this is our imaginary axis. So the point, we've got 3 plus 5i. Here's our origin. We're finding the distance from that point to the origin. So the distance formula, to jot that down again, is x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Our x values are our real numbers. So our first real number is 3, and the origin is 0, 0. So we've got 0, 0i. Plus our second piece, our imaginary part, is 5i minus 0i quantity squared. So when we're finding absolute value and finding distance with the origin, we're always going to be subtracting 0 or 0i. So the shortcut for this formula is real part squared plus imaginary part squared. Make sure with that imaginary part you put it in parentheses because we're going to square the 5 as well as the I. So the 3 squared becomes 9, 5 squared is 25, and I squared is I squared. Remember, I squared is 1, so we now have 9 plus 25, which is the square root of 34. 34 has no perfect square factors, so we can't simplify that. For part B, we have no real part. So when we're looking at the distance formula on this one, we'll have 0 minus 0 squared plus negative 7i minus 0i squared. Again, if you want to shortcut that, we get 0 squared plus negative 7i squared. Obviously 0 squared gives us 0. Negative 7 squared gives us 49 times I squared, which is 1. Square root of 49 is 7. And that is it. We'll see you in class tomorrow.